Okay, and let's go ahead and do these transformations now. Let's look at the one on the top. It is xy goes to x minus 3, y minus 2. Tori, how's it move the shape? Okay. Left 3, down 2. So if you want to use your patty paper, you can trace that shape and move the entire shape at once. If you didn't grab patty paper and you want it, it's at the back. Otherwise, just take each point, move it left 3, down 2, and graph your new shape. Go ahead and do that now. Whenever you graph the new points, remember you need to label them with the prime symbol. So we put P prime with an apostrophe to show that it's been transformed. It should look exactly like the same shape, just in a different spot. Check yours with mine, make sure it looks the same. And let's talk about the next one. Luke, so xy goes to x, y minus 4. How does that move the shape?
So it just goes down 4.
Right. So the x value does nothing. Doesn't change at all, but the y is minus 4, so yeah, he's right, down 4 is all it does. So take your shape and move each point down 4. If you went left, that's incorrect because the x value didn't do anything, so take each point down 4. And Q should be, Q prime ends up at the same spot as P. So they're overlapping, that's okay. So yours looks like this, and you probably did it right. Could you please write the coordinate rules for that bottom section? I will do one example on the board. I want you to try the rest. This front page is basically a review of what we did yesterday. So remember when we write coordinate rules, you have to write the original point, x, y, and then with an arrow goes to the new rule. So x comma y with an arrow, and that goes left 4, so it would be x minus 4, and down 2, so y minus 2. Can you please write the next 3 rules if you have not already? This next one would be going, since it's right 1 and then down 1, it's, so your original point goes to right is always plus, so x plus 2, and down is always minus 1 for the y's. Next guy, right 6, up 3, so they're both positive. Right 6 would be x plus 6. Up 3 would be y plus 3. And then the last one, left 0, down 6, that would be x, y. Since it doesn't go left or right at all, we just put x. That has not changed. But down 6 is y minus 6. Okay, let's move on to rigid motions. A rigid motion is a transformation that preserves the length and angle measure, also called an isometry. So basically the shape stays congruent even as you move it around. So is a translation a rigid motion? The answer would be yes, because the shape stays congruent. Or specifically, the side lengths and the angles stay congruent. All that's changing is the location. Okay, a composition is when you're doing 2 or more transformations in one problem. And if those transformations are rigid motions, then the whole thing should be rigid motion. So let's go ahead and graph RST. We know that our transformations, we're going to do, this is our original, make that like 0. And then we'll do this one first, and we'll do x plus 1, y plus 5, we'll do that second. So there's 3 things that need to happen, the original, and then 2 transformations. We do not go back to the original shape when we do a transformation in this shape. So this one, we're going to take our original shape and go right 6, down 3, because it's plus 6 minus 3. Go ahead and do that. So it ends up right here. And then the next transformation is x plus 1, y plus 5. We're going to go from the blue shape and transform from there. So we're going right 1, up 5. Go ahead and do that from the blue shape. Notice how I labeled it R double prime, S double prime, and T double prime because it is the second transformation we're doing. So here's the original. We went from the original to this blue one. We did not go back to the original. We started from the blue one and went to the black shape. So that's a composition.